As a conductor, I hope you are doing well. Before I start my presentation, I would like to introduce my group member. First is my name is Muhammad Kayyum Roslan. Second is Aika Zimbe Faizal. Third is Putra Zahirul bin Samsudin. Fourth is Nik Muhammad Aikan bin Nik Abdul Razak. Five is Josie bin Lego. C is Muhammad Syukri Iman bin Sahami. Now I want to intro language interpolation. What is a language interpolation? Language interpolation is a numerical method used to construct a polynomial function based on a given set of unknown data points. This method allows us to estimate the value of a function at a point between the known data without knowing the original function explicitly. It is especially useful when experimental or the discrete data is available, but the access a mathematical relationship between the variable is unknown. By using a language interpolation, a unique polynomial can be formed that pass exactly to all the given data point, making it a reliable tool for the approximation in a numerical analysis, engineering, and scientific application.
Hi and Assalamualaikum, my name is Putra Zahirul bin Samsudin. Now we will move to basic concept of interpolation. Interpolation is used to estimate unknown value from known data points. It finds value between the given points, and the result will be a smooth curve created through all data points. In Lagrange interpolation, the curve is a polynomial. For example, we can estimate temperature at 9 am using data from 8 am and 10 am. For example, 8 am the temperature is 24 Celsius and 10 am the temperature is 28 Celsius. And for the 9 am the temperature is unknown, so we just need to create a graph and plot the known data, which is 8 am and 10 am. After that, we will get the 9 am temperature, which is 26 Celsius. That's all from me. I will pass to the next person.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Syukri Iman bin Sahami. So next part, I will explain the theory of the Lagrange interpolation. First of all, Lagrange interpolation is a numerical method used to construct a polynomial that pass through a given data point. So, if see the graph, for n plus 1 distinct data point, there exists one unique polynomial of degree, and that fits exactly at all known data point, and only one curve can fit all the point. So each data point has one basis polynomial. It is equal to 1 and at its own point and equal to 0 at all other points. Okay, so see the graph. When all basis polynomial are combined, the final interpolation polynomial is obtained, which pass through all the data point. So last of all, easy way to understand Lagrange interpolation theory explain how a unique polynomial curve is constructed so that it pass exactly through all given data point. So that's all from me. I will give to the next person.
Now we're going to move on to Lagrange interpolation formula. So the formula goes like this. Fx equals L0x Fx0 plus L1x Fx1 plus L2x Fx2. So now what are the terms used in this formula? First, we're going to move on to the L. What does the L mean? The L represents each known data point we're going to use. So we're going to move on to the steps for the formula now. For the first step, we're going to go to L0. So L0 equals x minus x1 and x minus x2 divided by x0 minus x1 times x0 minus x2. As we can see here, there are two parts in this equation, the top part and the bottom part. The top part is the numerator, which holds the variable x, and the bottom part holds the constant x0, which uses all the known data point we have. Okay, the top part, the numerator, is used to find the value of x0, while the bottom part, the denominator, is a constant x0. Role is to scale the numerator so that when x equal x0, the whole expression become exactly 1. Now let's check out step 2, which is L1. So the simple thing here we can see is that x1 from the first step is replaced with x0. As you can see, x minus x0 times x minus x2 divided by x1 minus x0 times x1 minus x2. We can clearly see here that x1 has now become the constant in the denominator, while on the numerator we are trying to find the value of x1. So that's the simple change we can think of when going on to the next step, which is where whatever data point we are using, we are trying to find, we will use it as a constant below and as the endpoint in which the value we want to find for the top part. Now let's check out the third step, which is L2, or in this example, the final step. So in the L2, as you can see, there are no longer x2 on the numerator. This is because we are trying to find x2 value by deducting x value with x0 and x1. And also, as we can see, the denominator below now uses x2 as the constant, since we are trying to use it to gain 1 from this whole expression. Okay, what happens if we add L3? The answer is simple. Now instead of 3 steps, there will be 4 steps, ranging from L0 until L3. And what happens to the expression? It's also simple. You just have to add another expression. For example, for L0 step, we just have to add x minus x3, and on the bottom part, x0 minus x3. So that is it for the formula.
Okay, let's proceed to the next part, which is example of question and solution for Lagrange interpolation. In Lagrange interpolation, usually it provides a table consists of iteration 0, 1, 2, 3, 4, 5, it will be until 8, 7. It also give a value of s and fs, and it will correspond to each other as in the question 1 to 2, 2 to 5, 4 to 17. And the question asks, based on table above, by using Lagrange interpolation, estimate value f3. As we know, there is no value for 3. It's a 1, 2 till 4. So we need to find. So let's try to find by using the formula given, explained by my friend just now, which is Josie Branlico. So let's try. First, we need to find L0x. So we will take a target variable, which is 3, and we'll minus all value except the x1. So 3 minus 2, 3 minus 4, divided by all x value will minus the other one. Say 1 minus 2, 1 minus 4. So let's try calculate it. 3 minus 2, 3 minus 4. And divide it, we got negative 1/3. And we need to multiply it with the corresponding value of x, which is fx2. So negative 1/3 multiply 2. So negative 1/3 multiply 2, we got negative 2/3. Okay, let's move to the next one. L1, target variable. So 3 will minus all target variable except the second column of x. So 3 minus 2, 3 minus 1, and 3 minus 4. Divided by 2 will be minus all value for x. 2 minus 1 and 2 minus 4. So we try calculate 2 minus 1, 3 minus 4. Then we got 1. Then we need to multiply to the corresponding value, which is 1 multiply 5. 1 multiply 5 equivalent to 5. So last one, L2x. So target variable will be minus all value except the third one, which is 4. So 3 minus 1, 3 minus 2. And value of 4 will minus 1 and minus 2. Again, we calculate it using our own calculator. Blah, blah, blah. And we get 1/3. And we need to multiply to corresponding value of 2, which is corresponding value to 4, which is 17. And we try calculate it. We got 5.6667. So the all value will be sum negative 2/3 plus 5 plus 5.6667. So we got the answer is 10. So that is estimate value of F3. That's all, guys. Let's proceed to the conclusion. Thank you.
Now we move to the final part, which is conclusion. Lagrange interpolation is just a method for constructing a polynomial that passes exactly through a set of given data. It is easy to apply because it does not require solving simultaneous equation. However, it will become inefficient if we have a large number of data points. So it best to be used when we have a small data sets and basic interpolation problem. That's all from us. Thank you.